Last time I talked about the hindbrain, what it is and what it's responsible for. This is the second part of a three-part series about different parts of the brainstem: the hindbrain, the midbrain, and the forebrain. To begin, let me answer a basic question. What is the midbrain? Well, the midbrain, also known as the mesencephalon, is a tiny part of the brainstem that's quite important. It is located just above the spinal cord, but not too far up as it is below the forebrain. And even though it's very tiny, as shown by the green in this picture, compared to its other counterparts, the forebrain and the midbrain, it controls important functions. These such important functions are mainly sensory information, muscle coordination, and embryonic development. Some important structures of the midbrain are the tegmentum, the substantia nigra, the cerebral peduncles, and the reticular formation. So, first up is the tegmentum. This structure is necessary to maintain our unconscious homeostatic and reflexive pathways, and the control center that maintains such pathways provides signals to the thalamus and basal ganglia to limit any undesirable body movements. This can be similar to a receptor in a feedback loop or in your feedback inhibition pathways. Furthermore, it houses the cranial nerves nuclei, which are located in the spinal cord, specifically cranial nerves 3 and 4. Next is the substantia nigra. It is associated with motor system pathways, similar to the pathways associated with the tegmentum. It works with the basal ganglia here. It also produces a neurotransmitter known as dopamine, which is necessary for motivation and habituation in mammal species in our brains. After that are the cerebral peduncles. They are located on the sides of the midbrain anteriorly and help connect the midbrain to the thalamus. They are pivotal to maintaining motor movement such as refinement, learning, and balance and posture. So over here, this is the brainstem, and this is the cerebral peduncle, which is at the top of the midbrain area. Last is the reticular formation. It consists of more than 100 neural networks, which is a crazy amount. And these neural networks all work together to perform varied functions, which are quite important to the reticular formation. Such are the somatic motor control, cardiovascular control, pain modulation, sleep and consciousness, habituation, and detecting salience. Damage to the reticular formation is devastating as it can alter consciousness and lead to increased fatigue in our bodies. This is through chronic fatigue syndrome. Essentially, the reticular formation is very important to maintain our circadian rhythms, which are basically our sleep-wake cycles that regulate when we want to sleep, when we want to become awake. And that is some information about the midbrain and the brain. Thank you all for listening, and be sure to stay tuned for the last part, as well as more videos about our interesting organ known as the brain.